Good. Okay, it's really bad. Um, okay, so, but I'm surprised. Like say, uh, it's extremely bad for comprehensive problem 1. Okay, but have you seen this problem before? Test.
How do you say what?
Have you seen the comprehensive problem 1 before the test? No?
Yes.
Yeah, you asked
But
us.
it's exactly the same problem from the homework 13.
Yes.
I even forget to change the number. So, okay, so I guess the lesson is that I know it seems that we people have different way to try to believe that's your way to prepare tests. Some of you only review the notes, but don't do the homework. Some of you may do the homework, but don't review the notes. Okay. I also noticed there are students finish all the calculation problem pretty well, but get 0 for conceptual parts. Okay. So you need to think about, you need to review everything. Well, I have students here. They did everything very well, but black for one problem, this problem. So I guess, so you need to think about, you need to review both the notes and the homework and also read the textbook, okay? Because you can see, I told you the format of the test. You have conceptual question, you have simple calculation, you have comprehensive calculation, okay? Comprehensive calculation mostly from the homework. And the simple calculation and the conceptual, of course, they're from, you need to review the notes and textbooks. Okay? And also, I can point out, simple calculation 1, if you did the homework, you will know it is a very simple calculation. Okay? There are students think, okay, this is not simple. I saw a question mark on the simple word, so you probably don't think that is simple, but it is simple. And also for the second problem, it's the integral, okay? I checked the learning outcome for calculus 1. You all passed calculus 1, right? Otherwise, you cannot register for this class. That's a very straightforward integral. You just need to do the integral twice. Okay, but again, many of you can get this problem. So we need to think about all these fundamental things we learned. Okay, the comprehensive problem 2 a little is better. Okay, it's very hard to get the right answer. I didn't get the right answer for my first 2 calculations. I calculated 3 times, I get the right answer. But for this problem, it's easy to get partial credits. If you write down all the equations, you will get 6 or 7 equations.
For future, if possible, this is only a suggestion. If you yourself cannot get it the first time, please do not put it on the test because
do not put what on the test?
Don't put it on the test. The possibility of me getting it the first time is very low if you couldn't get it the first time. It's only a suggestion.
But I didn't get your suggestion.
Oh,
if you can't do it, we can't do it.
Don't put it on the test. Put one of those you like, I got it the first time.
I didn't say I can do it.
You didn't get the right answer.
I didn't get the correct answer for my first 2 calculations because I don't have calculators. Frankly speaking, I'm not very good at using calculators. I never use calculators. So complicated calculation, I have to program it. For simple calculation, I can only do it by hand. And of course, because getting the right answer, sometimes even you use a calculator, you may make a mistake. I know that. So I didn't put a lot of points for the final answer. Okay.
So, always going over the tip like.
Any other suggestion?
So one, if you have time, and you're like, did you go over at least one of the problems?
Of course I can go. If you have, you can ask me any problem here. I can explain it, right? Yeah. Or do I need to go through all of them?
Yeah.
That'd be good. Okay, let's do that. Okay. I guess that's good because that's first case out. Hope you can think about that, and so you know what you should do to prepare the future. That's okay. And also that's a basis for other units. Okay, so question A, multiple choice. Newton's third law states that action and reaction forces are equal but oppositely directed. How can there ever be a net force acted on an object? So here we think we give several examples like how can you pull a car to move? Remember we have a bunch of discussion for Newton's third law. Okay, so the key point is that the right answer now you know it's A, right? Because action and reaction don't act on the same object, so they don't cancel each other. So when you use a force, so what do we mean that? Okay. So if you are trying to pull something, okay, the action is the force to pull the box, say. And the reaction is force acted on your body. They are equal and opposite. But they don't cancel each other because they are not in the same object. The force trying to cancel your action is not the reaction. It's another force, say the frictional force. Okay? But the frictional force may be not large enough to cancel your action. So in that case, you can pull it and make it move. Okay, so that's what A says. And you can check B, C, D, they're not right. B, the action and reaction doesn't act on the same time. They always act on the same time, action and reaction. The action force acted on the object in this case is unpaired with reaction. No, that's the key point of the Newton's third law. Every action comes with reaction. Okay. And D, the Newton's third law, Newton's laws don't apply in this situation, and quantum mechanics has to explain it. No, this is a very straightforward case. We don't need anything like quantum mechanics. Okay, Newton's laws apply. Okay, and B, what happens to a parachute when the upward force of air resistance is equal to the downward force of gravity? So the right answer is B. Okay, many of you choose A. What's wrong with A? So you probably think about the acceleration. When it reaches the terminal velocity, when the two forces balance each other, according to Newton's second law, you don't have any net force. So acceleration is zero. But please note that acceleration is zero means the velocity is a constant. Okay? We emphasize this relationship again and again. So you need to be careful with that. Okay? Velocity, acceleration, which quantity we are talking about. D, which force depends on the velocity? I think we mentioned this in the class. Only the air resistance. Air resistance, D equals to 1/2 something v squared, right? So larger velocity, larger air resistance. But other things like, say, remember frictional force, they are usually in the form like mu, for example, kinetic energy mu Ka. It has nothing to do with velocity, right? So, similar for the kinetic friction, state friction, and rolling friction. Okay, see, 4, if a particle moves with a constant speed but changing direction, which of the following statement is true? Okay, the right answer is C. In this case, the acceleration is perpendicular to the velocity. many of you would choose A, acceleration must be 0. What's wrong with this?
You need acceleration to change direction.
Okay, so if it's constant velocity, then acceleration would be 0. But okay, I emphasize this is constant speed, I even underscore it. And it has changing direction. Okay. So in that case, it's actually the circular motion, uniform circular motion. So the acceleration is perpendicular to the velocity. If the acceleration is perpendicular to the velocity, it will change the direction, but not the speed, not the magnitude. Right? If the acceleration is in the same direction of the velocity, it will change the magnitude, but not the direction. Okay, remember this. So all these things we discussed in the class. Okay, it's also in the notes. So you need to pay attention to these things. Okay, finally D, a simple pendulum is released from an angle of 30 degrees to the vertical. During the motion from the releasing point to the lowest point, which of the following statement is not true? Okay. So if you release pendulum from like 30 degrees to the lowest point, the first thing I think most of you would agree that the speed A is correct. The speed increases, right? 0, initially 0, and getting larger and larger. And then, once you identify speed increases, you should identify B and C are correct. Okay, because centripetal acceleration equals to V squared over R. So if the speed increases, centripetal acceleration also increases. Okay, so B is correct. C, the air resistance is increases because air resistance also depends on the velocity, right? So when speed increases, air resistance increases. So the only thing cannot be right is D, the gravitational force increases. Okay, so here W equals to mg is a constant. Okay.
Gravitational force will never increase, right? It's a constant.
If approximately, if we consider simple case like close to the Earth's surface, later we are going to study the universal gravitation. If you consider gravitational force between like the sun and the Earth, also of course depends on the distance. Okay, some of you even ask me, should we consider that? We shouldn't, because we don't even learn the universal gravitational force so far, right? Okay, so any other question about the 5 conceptual problem? Okay.